All right, so far what we've done is we've found that the points to consider are all the points on this line, all the points on this line, all the points on this line, this one random point we found in the middle, and these 3 corner points. And we evaluated f for the 3 corner points and the one in the middle. And we also just finished this line right here, x plus c equals 1. We still have to evaluate f and find maximums or minimums along these remaining lines. This is a very long problem. I hope I warned you about that. So the second one I think was x1 minus x0 for the x plus y equals 1 line. So f is going to be equal to 4 minus 2x squared minus 1 minus x squared minus 0 squared. And hopefully you can see that that's actually going to simplify to the exact same minus 3x squared plus 2x plus 3 as before, which means f prime equal to minus 6x plus 2 equal to 0 tells us that x should be equal to a third. This is the same reasoning as we used above. It's just now the point to consider before was x0, 1 minus x, became 1/3, 0, 2/3. Now it's x, 1 minus x0, so that's 1/3, 2/3, 0. But f will have the exact same evaluation as before, giving us 3 1/3 for the answer. And before I move on, I haven't been boxing these, so I won't. I guess we'll just go back and select the ones we care about later. And then the last set of points we had were x is 0, y is whatever it wants to be, and z is 1 minus y. So that f equal to 4 minus 2x squared becomes 2 times 0 squared, minus y squared minus 1 minus y squared becomes 4 minus y squared minus 1 minus 2y plus y squared. Minus y squared is minus 2y squared, plus 2y plus 4 minus 1 is plus 3 is f. And if we want to maximize or minimize this, we could plug in every single value of y and see what happens, or we can use those handy tools we should remember from Calc 1, and we say, okay, the derivative of f is minus 4y plus 2. And when that's equal to 0, I'm at any of the possible maximums or minimums. So that tells me that y should be equal to 1/2. And if y is equal to 1/2, then the point to consider is going to be 0, 1/2. Oops. 1/2. 1 minus 1/2 is just 1/2. And at that point, f is equal to minus 2 times 1/2 squared plus 2 times 1/2 plus 3. Just plugging in that I solved y is equal to 1/2 to this value of f. And that's going to be 0, 1/2, 1/2, 3 1/2. If you wanted to go back to the original value of f that has x, y, and z in it and plug in this instead of plugging only the y value into the special f that has only the y value, you would get exactly the same thing. Plugging y into the thing you've already simplified to only have one input is probably a little bit faster, though. That's why I've shown it to you this way. So my last step is going to be to find the maximum and minimum. All the way back to the steps we're following here. We found our important points in the interior. We found our important points on the edges, and then we evaluated f for all the points. We took a slight shortcut here. We said evaluating f for every point on this line is hard. Instead, I'm going to say if I did do that, I would find the maximum or the minimum, which I can find using basic calculus by setting the derivative equal to 0. So this right here was kind of a shortcut. I don't know, I'll do like a little flag right there. So you know that that's a shortcut we took. That's a shortcut we took. And that's a shortcut we took. And we'll do like right here, shortcut. Find max / min using calculus instead of a million function evaluations. That's what that little flag sign means. Okay, but our last step has always been to look at everything we evaluated and find the largest and smallest ones. So I'm going to go look for my largest and smallest functions. This looks pretty small. F of 1, 0, 0 gave me f equal to 2. And 3 3/5, 3 1/3, 3 1/3, 3 1/2. 3 3/5 also looks really big. Big. Small. So what we find is the minimum occurs, the lowest temp occurs at, I think it was 1, 0, 0. 1, 0, 0. So F is equal to 2. That's the temperature function is 200 degrees Celsius. That's a minimum. And then the highest temperature occurs at the point 1/5, 2/5, 2/5 for 3 3/5. F is equal to 3 3/5. Is that right? Okay. And so this would be the answer to our question. I'll go ahead and put that in a big box. Oops. Just to remind you, using the maxima minima terminology, that's a maximum, that's a minimum. But the original question was to find the hottest and coldest parts of the plate. So we found the hottest part of the plate is right here. The coldest part of the plate is right here. Coldest, hottest. And that's the end of this problem. It was very long. This type of problem can be very long. I just wanted you to see one that has all 3 variables in it, but as you can see, it becomes very lengthy. So most, if not all, of your web work is going to be with these, more like the first example we did a million pages ago, where it is only in terms of 2 variables. So make sure you understand how to do this, but don't worry, I understand it takes a very long time to solve all those different equations.